general graphs. Now, we know that electrical networks are being represented in terms of the systems. Systems are represented as graphs. Graph theory that has been taught here in their basic electrical circuit fundamental subject, which is origination for solving the problems of electrical circuits and loop current and order laws. So, power systems is treated as a multi-input, multi-output network with buses are being represented as the infinite bus bar we know as the nodes in the graph. The bus bars are of various categories again. They are classified into generator buses, load buses, okay, and of course the slack bus and other. But I would like to say that the bus that is being connected, although they may be classified as generator, there can be light load or no load, or load also can be there. That means a bus can be a generator bus as well as a load bus also. Okay, only generation we not consider, because to maintain the generation there must be some load or some power supply is required for making the operations and to be monitored, and there will be employees or there may be other personnel who are working in that. So therefore some light load will be there or low load. It is equivalent to maybe no load itself. So that is how power system network are being treated as multi-input, multi-output networks. Okay. So reliability engineering applications is a probabilistic study of the power system operations. In the sense, there is no single reliability index with respect to the power system that is being classified. It is a separate subject by itself, which is being introduced 3 decades ago in our university campus college, 3 decades ago, nearly. Okay. And it has been taught with respect to power system reliability as a subject. Later, I got the opportunity to shift that into 2 subjects: system reliability concepts and power system reliability for power system engineers initially. Then, after starting MTech reliability engineering in 2009 in the university campus college, I made it system reliability concepts, and power system reliability is optional only to EEE students, like that. That is EEE students studying power system and the system reliability engineering course. Others also I got their other optional subjects as elective subjects. That is why they are open electives with respect to other departments also they take, like structural reliability and other subjects are also there, cyber security or even information security, like that, all related areas of reliability engineering applications. Now, reliability engineering applications with respect to the various classifications which I would like to make with power systems, with emphasis on reliability concepts, essentially with respect to the using the cut sets. What are cut sets and other things I will briefly mention here also, and what are the formula which you have derived, I will mention those things. And application of the reliability analysis using cut sets I will mention. That is first aspect. The second aspect will be in making the reliability optimization not as a mathematical tool but as a practical case study with respect to the loss reduction. We know the losses are more in the power system network, maintaining the voltage profile. Okay, then for every system there are certain indices that is called reliability indices. For example, power systems are classified as various classifications like subsystems. Power systems classified as various subsystems like generation subsystem, transmission subsystem. Combination of these two are called composite power system, or popularly known as bulk power system, interconnected system, substations, operating reserves, and so on, and also switching after faults and other. So these are some of the subsystems that are being classified in the power system configuration for various maintenance strategies or otherwise. And for each subsystem, some of our old students in PG courses at the University Campus College, when I was teaching for the past 2 decades, this particular subject as first semester as a mathematical tool, they know, or we used to say that each subsystem have got separate indices. What are those indices? Reliability indices. What we have thought about only is the reliability index of the system, which has been stated for reliability optimization and other things. There are two classifications of the indices which I can think about, or which has been broadly classified into as basic probability indices, which I will discuss in today's talk, and also performance indices. The performance indices with respect to the generation subsystem reliability analysis is different. Transmission system reliability analysis are different. The conditions, the constraints, the operational details are different. Therefore, the indices also will be different. They will be made as meaningful to those subsystems. Reliability that way is not only just the index whose value lies between 0 and 1. Reliability index is also the index whose value lies between 0 and 1. What are those indices? I will discuss based on the basic probability indices and general network probability configurations. Okay, called failure rate, repair time, and average annual outage time, mean outage time, etc. for each subsystem. Then performance indices. Their performance indices are being classified based on various subsystems again. What is meant by performance index? The purpose of the generation system is to give the generation such that there will be no loss of load. It is a typical term. It is not the loss of load means load is not being lost somewhere. If the generation is not able to meet the required load demand, or the generation is less than the load demand, in other words, the load demand is more than the generation, then in the reliability terminology that is called loss of load. Then what is the probability of the loss of load? That is called loss of load expectation, is one of the parameters of estimation. Similarly, loss of energy, loss of expected energy, loss of load is in megawatts, loss of expected load will be in per unit values, or maybe whose value may lie between 0 and 1, or maybe the loss of load may take place between duration of the hours per year. That is here in terms of the number of the occurrences we call. That is the type of the called frequency of occurrences. It is not the conventional power supply frequency. The frequency here we mean to say that the number of times of the loss of load that can take place, loss of load expectation, loss of load probability, the frequency of occurrence of the loss of load, etc. So similarly, that is how many number of times the load is exceeding the generation. Because load is unpredictable. Generation, we have to meet the required load demand always. Always it should be matching. But the data that is being given in by the pioneers in this field is Roy Billington and Ellen. Roy Billington is 80 plus now, is staying in Canada, who is number one in the world, who is the chief editor of IEEE Transactions on Reliability, and his student, Professor Ellen, also staying in Canada and USA, they are neighboring countries. So both of them are having neighboring attitudes. And Professor Ellen is a student of Professor Billington. They have written the book together. And it is only a privilege to claim that Professor Ellen was my PhD external thesis evaluator, that is examiner, when I did my PhD at IIT Delhi. That is, he has evaluated one of the examiners. There will be two examiners, one from India, one from outside India. So Indian examiner is from IIT Mumbai. He is retired, Professor S.K. Banerjee, in reliability engineering group, and Professor Ellen. So that is how I am the follower of the book Reliability Evaluation of Engineering System by Billington and Ellen group, and also Reliability Evaluation of Power Systems by the same group. The next one is also written by them, third volume I would like to call, but that is, I have not even discussed some of the methods. They are advanced topics. Monte Carlo simulation technique, applications to the power system. Monte Carlo simulation is a non-deterministic approach based on the large number of randoms of sampling that have been taken. Anyway, that is out of scope in today's topic. So this is only a background to introduce you how reliability engineering comes into the network modeling and network modeling to power system modeling and etc. And now later I will explain about the power system regular configuration rate, the loss reduction techniques for radial distribution networks, switching stations, and then application of the network reconfiguration separately, that is without reconfiguration, best case solution, with reconfiguration, computation of the reliability indices, then incorporation of the DG, distributed generation. We know distribution generation or distributed generation can be taken as solar or wind, fuel cells, or any other combination based on the necessity, not the conventional ones. So new and renewable energy sources as the distributed generation. Although when we have prepared these thesis and other things 6 years back, the thesis work that is being done, it is still in the preliminary stage of the solar power as a distributed generation alone for low power to some medium level of capacities. But now it has been generating in terms of the megawatts or even sometimes gigawatts of plants are being commissioned nowadays. So we need to think, that is where from this data to subsequently our next reliability analysis talks will maybe applicate to the data analytics, that is big data application, no exaggeration. So we need to build slowly. If you conduct a similar, I suggest big data applications to power systems with the reliability is another topic that we can discuss subsequently. Although we are not exposed, but we need to get exposure ourselves, studying ourselves and then working on those things so that you can guide the PG students in collaboration with the computer science faculty. Okay, big data analysis is prominently adopted by them or developed by them. Always we are the users, that is always there. Okay. Now, so this is the main essence of the today topic. So I would like to mention what is the content. If there is any difficulty, the organizers, Madam Lakshmi, you just mention whether the disconnection is there, or audible levels are not there. Otherwise, I assume that I keep on talking. Because in this, okay, Madam? Somebody should respond. If there is any disturbance or discontinuity or unable to listen, or there is a problem, somebody has to give the response. Otherwise, my lecture will be one-sided. We will not be knowing others whether they are listening or not. So I need to know about the organizers, because organizers only can allow the participants to, unless they unmute the students or participants, give the access, they cannot make it. So therefore, one of the organizers must always be available to make any disconnection is there or any audible levels are there or even presentation is not being visible to you and other things. So I want to make it a point. So I think maybe it's okay. Yeah.
Sir, we are following, sir. No problem.
Yeah. Thank you. Yeah. So I just want to remind you, if any such disturbance is there, immediately obstruct the flow so that we can check the problem if it is there. Okay. Otherwise, I assume that things are going on. Otherwise, I assume that things are going on well, right?
Yes, sir. Okay, sir.
Yeah. So the contents are scope of the presentation, of course, an introduction. As I mentioned, it is 3 classifications I have made in my presentation. Reliability analysis of power system networks using cut sets. What is a cut set and other things, I will mention those things also. Although we know about, but why it is being given a separate identity of the topic and other things I will explain as far as the reliability applications are concerned. Of course, loss reduction or loss mitigation. We cannot assume that loss to be avoided. No. System to system, configuration to configuration, place to place, losses will be there. We can only minimize, we cannot avoid them. We can only mitigate. Mitigate, reduce, or reducing the losses. We cannot see reducing the losses is improvement in reliability that way of the system. Here, reliability optimization using network reconfiguration. Reliability optimization is with respect to improvement in the performance. No mathematical tools are being used except the conventional analysis is being used, but with respect to the performance indices, there is an improvement. Still, it is a wide open task of implementation of the various reliability optimization mathematical models for power system load flow solution problems. Okay, not much attention has been done in that particular direction. Okay, because we are interested in the improvement in the reliability or reduction in the losses. maintaining the voltage profile. Ideally, voltage profile means the ideal base case value of 1.0 per unit should be maintained. Otherwise, tolerance of 2% earlier, 5% in the earlier literature of even 50 years, 30 years, 20 years, like that. After 20 years, people have realized that 2% is too ideal situation. Although ideal is most ideal is 0% of voltage variation. Okay, then 5% is tolerable up to 10 decade. Now people are saying that up to 10%, okay, people will think about it. Less than 10%, it is considered as ill-conditioned network. So if the base case solution of the load flow is less than 0.9, there is a need for improving the voltage profile also. So simultaneously, you have to maintain the voltage profile within the acceptable limit, improve, or if it is 5% up to 0.95 or 1.05, plus or minus 5%. So you have to, if it is already within the acceptable limit, there is no need to go for any improvement strategies. Then the question comes, what is your realizable voltage per unit? 0.99, ideally 1.0, it is impossible. So 0.97, that is 3%, like that. So 0.96, 94, 93 is called as you need to improve. Otherwise, if you do acceptable limit, you say world standard ones is 2%. Some national standards is 5%. Okay. Less than that, if you think it is an ill-conditioned network, there is a scope for improvement. 10% is worst case. Beyond that, it is no network at all. So you cannot use them. Okay. We are not supposed to use them. So shut down the load till the normalcy is being restored, and provide alternate backup through switching stations or other means. That is how you need to optimize. Okay. Even in the pandemic situation, the load also should not be there. Okay, that is more dangerous because voltage profile less than the certain one is causing more panicking in getting short circuits or thermal problems and other things. The greatest analysis has been done during the pandemic situation, during the period when the national blackout has been done for even just for a few minutes, when lighting of the power supply has been taken off and we have used the incandescent lamps for the lighting load with incandescent lamps or lanterns also people have used, or with other just only light with that are being used in temples, etc. Very light loads. Okay. So in such situations, analysis has been made, and I attended that lecture, which is being organized by National Power Grid Corporation and IISc Bangalore professor retired, and he has got his own software consultant, Professor Nagaraja. They have organized this particular electricity boards and other things. It is a reliability problem. The government, central government, has discussed with the pioneers, experts in the corresponding field. Can we take out the power supply during the corresponding at 9 p.m., which is huge load will be there. Industrial load will be there, domestic load will be there, fridges, air conditioners, and so many other loads will be there. Suddenly, if you switch off everything and make it as a light load, how much time we can do it? So, a lot of analysis, prediction has been done, a lot of analysis has been done, and people have given the confidence that yes, government can go ahead with that. Because it is predicted, and the total performance of the national grid has been estimated, and it has sustained. There was a drop, definitely drop in the voltage and the power use, and there is voltage drop and power loss also is there, etc. Power not being utilized, but it is not that one. Okay, so all these things comes under reliability analysis only. So pandemic situation has given us a lot of scope for various alternative strategies for making these things. Then industrial automation people, IoT application, IIoT application, all these things are made, and out of own interest and to keep ourselves updated, I am just attending to those lectures also. Not as the master, but as a learner. Because as a teacher, I believe strongly that a teacher is an ever-learning student. So therefore, we have to keep ourselves updated. Otherwise, we'll be will be taken as fast riders. Okay. Anyway, So these are necessity of the reliability analysis that has to be made. Okay. Although it is done since now nearly 6 decades in the world, I think first 1957 when there is a total blackout in the nation, in some parts of the states of the United States of, that is USA, United States of America, they thought predictive assessment need to be made. Nearly it is in 1957. Earlier, there was no necessity, means there was no fatigue or fatal failures. So the necessity has made us to invent the corresponding models and predictive assessments are come now. I should not say that, okay, somebody has done it, okay. But today, are they still valid? Can we improve further? So that has come to that stage to 1957 to the total blackout prediction stage. And without immediately, after the 5 minutes that has been taken within half an hour or 15 minutes time, the total recovery of the supply voltage and the power supply is being connected. And still no damage has been done in the pandemic situation. So that stage to this stage, we have come to the analysis part in the world. Okay. So it is not the nation problem alone. It is a worldwide problem. And we talk about grids. When I asked one person who is an international expert, international grids also they have been connected to the neighboring countries. Okay. The wide open problem is whether power system reliability aspect to improve the reliability of the power system means power system to meet the generation or the load. We are able to communicate through mobiles worldwide. We are able to communicate through communication through microwave channels. But can we do it in the power side? So far, no, nothing has been done. Only through overhead lines. Remotely operated has not been taken up. Means still, people, there is a lot of scope. Can we use from one country power supply to the other country? Other than the grid connection, there is of course neighboring countries always have got. Power sharing is there. Just as neighboring states we have got, neighboring districts we have got, neighboring countries also they have been taken up. I do not want to name the countries and other things. So based on the bilateral relations of those things, still we are using the power supply from one country to the other, transferring the power, utilizing the bilateral grid connections. So power system problems are that way quite complex, and everyone needs, being a branded as power system engineer, we need to understand, study, and then improvise the performances. Although we have got theoretical concepts only, but given the opportunity, can you be the consultant for these things? That is where we need to bridge the gap between the institution and industry. So we need to bridge the gap. There is a vast difference between the theoretical and the practical ones. But now people are thinking in terms of these things. Because the industry people are doing with trial and error methods. That is probabilistic, heuristic methods. We are conversant with theoretical ones or standard system. But practical case studies may be something different. Now people have been allowing. Earlier they used to say that it is confidential. Electricity boards are giving the data. Distribution substations are giving data. Governments are giving the data. National grid people, Central Electricity Authority is giving data. Provided you use them confidentially for research analysis only. Then they permit. So authorized persons, if they apply for giving the data, you can always get it through official channels. Otherwise, people are so clever nowadays. Unethical practices. Hacking is permitted by military people, but unethical hacking is coming up. Even softwares are getting collapsed. Even software reliability implies the protection of the software that is being developed. Safety of the software. That is one of the analysis. Recently, I listened to a lecture which is organized by our computer science computer science department faculty. So similarly, our system solutions are also automated. Automation process means it is only through automated software that is being developed. So therefore, security and reliability of these things with respect to the safe and productive and sure of operation are very much essential in the day-to-day context. That is why what we are doing is only just elementary thought-provoking concept. This is not the end of it. Today I am making a beginning for your next thought-provoking idea. That is one. Okay? Right? So in that context, I want to just go to the actual present area. So, as I told you, the power systems are being classified into various subsystems. My analysis only today will be restricted to radial distribution systems. Because radial distribution systems are the ones which are directly related to the consumer perspective. Always, although generation, unless there is generation, unless there is transmission, unless it is reaches to the consumer point of view, which is respect to the distribution feeders, we cannot. But they are all independent identity. Making a combined one for all these things is still, at a subsystem point of view, we need to do it. I mean, as a system as a whole. But a power system being wide and large and we can say infinitely large, but it's not infinity. Okay? Because the traveling wave velocity is 3 to 10 power 8 meters per second. Distance doesn't matter. Okay? So therefore, it runs into kilometers and etc. But still, the connectivity is that much fast. So 3 into 10 power 8 meters per second as the velocity of the light. So power waves, that is voltage waves and current waves are of the same velocity it travels. So once it is connected, we have to take all these things into consideration. So that is well known. But why the importance is being given? Although everywhere the fields are there, it is everybody's interest. So those who got that interest in that particular field, they can always work. So I'll be just mentioning about otherwise I'm not discussing the entire power system subject here. A part, very just a minute part of the radial distribution system, and definitely it has got advantage over the ring main systems, so that but ring main systems also can be taken up where switching, that is switches can be used, where thereby the ring main system you can have switches that can be placed. Okay, so those switches can make the system to be radial, and there is a need for it. So alternate switching is called reconfiguration network using the switches to make the non-radial distribution to make into radial distribution system. That is what we would like to explore the possibility, which has been done about 6 years ago as a part of the research work from our student perspective. Okay, he has been awarded and he is working as associate professor in one of the colleges in Hyderabad. Okay, so electrical power distribution systems are being planned and built as weakly metro network, but these will be operated as radial. That's what I said. I'm not reading only the sentences, I'm giving the gist also somewhere. Okay, and the disadvantage of the ring main systems is that directly using them into the radial distribution system with switches is there will be have the disadvantage of the lower short circuit currents, and protection equipment is also definitely needs a lot of attention. Okay, so all those things have to be taken into consideration. Ultimately, whether it is radial distribution network or any other network which we want to make it as radially operated distribution network, it is in that context we would like to comment on the simple basic analysis which we have done on the radial distribution network. So that is what switching phenomena I mentioned that as tie switches. They are called tie switches, along with circuit breakers, disconnectors, laterals. There are some of the components of this. Okay, fuses, then laterals, disconnectors, circuit breakers, tie switches, and the connecting the circuit breakers at what end? At the supply end, or at the fader point of view, or at the load end, or at every point. Because it is not a network which is being shown, not just a pictorial diagram. It runs into, the distribution systems of a few kilometers. But transmission line goes into tens of kilometers to hundreds of kilometers also, based on the short line, medium line, and long line. Anyway, so this is the reconfiguration is possible with respect to mainly that is on the distribution network configuration. So tie switches along with circuit at the beginning of each fader are used for reconfiguration network when needed. Okay, so my concern is reliability analysis cut sets one aspect, then reliability analysis with the radial distribution network with switches that is permitted using that is called network reconfiguration sample model. Then incorporation of the DG for small system may not be permissible, which we could do for 6 bus system 33 and 16, and also we have tried up to 33 bus we have done. But some simple analysis is possible for 6 bus system, where with the DG the results are significant only in the 33 bus system. Therefore, I have made a case study of the 33 bus system here. In the thesis, he has done for 6 bus system, 33 bus system, and all this and all those things for each of these classifications. Thesis presentation is different. Okay. So, what is network reconfiguration is already known. So, basic concepts are known. That is assumed at this stage because we are all faculty members. Of course, with the advent of electrical and electronics, some people power systems has in BTech level has been narrowed down. Scope has been narrowed down. But in MTech, especially in power system, it is a basic study because most of the times I have observed power electronics people or control system people are not studying some of these power system concepts. So that way, a power system has been made as a specialized topic. Where earlier power systems is a common subject. People think electrical engineering means only power system people. Now it's not like that. No, even electronics and communication people can work in embedded systems area application to power systems now. That is the versatility. Computer science people, big data applications, or even optimization technique people can work in power system applications for reliability optimization. So like that, it is a interdisciplinary area now or multidisciplinary area. So anyway, network reconfiguration. If you are not familiar, just understand this particular one. Otherwise, it is a well-known concept, even more than 3 to 4 decades. It is an operation strategy which alters topological structure of the distribution fader by rearranging the status of the switches in order to obtain optimal configuration, optimal reliability configuration, optimization configuration. That is, optimal power flow is another concept in optimization techniques. So here we talk in terms of the optimizing the performance of the indices. What are those indices? I will classify them also. I will explain them also. Okay, which reduce the system losses and improve the reliability. Improving the reliability not by just index of 0 to 1, but based on the parameters. Some of the improving the reliability implies some of the parameters need to be reduced. For example, loss cannot be increased for your estimation. So loss has to be reduced. So also reliability has to be increased. Instead of computing the reliability, it is always convenient to realize the importance of the unavailability, that is unreliability of the system. So reliability, unavailability. Okay. And availability, unavailability. Probability of success is reliability. Probability of failure is unreliability. Probability of the success over a particular period of time or by and large as time tends to infinity is called availability of the component at any instant of time is availability at that particular time. Availability by broad sense, just as the prediction of the component is a successful component or say deterministic probability value that is being assigned by statistics people, that is probability of success of the component or a particular system or a particular configuration in terms of that. So similarly, so here in terms of the Markov processes, which I have not mentioned in the earlier talk, in the basic system reliability concept that has been done last month, is that the availability of the component in the long run or at a particular time, that is not referred to as the availability. So probability of success, reliability, availability. Probability of failure, unavailability, and probability of failure or probability of failure, unavailability, and then corresponding is probability of failure is unreliability, unavailability, like that. Okay. So just improve the reliability. Now, one of the most popular approaches, reliability means custom approach. Now I need to mention it is no way different from what we have studied in our elementary electrical engineering circuit subjects. Now, what is the difference between those concepts, what we have studied earlier, what we could extrapolate the corresponding one in terms of the reliability analysis, I would like to explore. Now, I start from fundamental definition of the concept. Cut set is a minimal set of edges whose removal from the graph isolates at least one vertex from the source. That means node gets isolated means there is no possibility of power transmission from one node to the other. Maybe from multi-input, multi-output network source to from various buses to one node or any other load point. Here the load is taken as the load point. A load point is taken as load because the number of consumers or customers that are being connected at that particular load point. So instead of node as in a graph, that is now called as a load point. A load point may not be directly connected at that heavy load, but that can be a radially distributed load. That is the present trend. Even in the composite power system that is being considered, a load has been taken as a radial distribution feeder to segregate the different consumers at different points. And at a particular bus of the load point, there can be several consumers. Okay. So how much load is being there at a particular load point among the radial feeders at a particular bus in the power system network, which is composite power system network, where generators versus transmission lines, transformers, other things are there. So all these things are interconnected. Slowly it is coming up fast. And then improving the performance of these things as the load increases, we need to improve the voltage profiles, reduction in the losses, improvement in the performances. So therefore, you need to augment the power supply. How to augment the power supply? Overnight, we cannot increase the power supply with respect to the conventional power source. So you need to have some backup. So thermal systems earlier as base peak load plants that are being there, base load plants, peak load plants, all those things you might have studied in power plant engineering by mechanical or electrical students, right? So, and similarly, hydroelectric plants are also being useful. So, in addition to those things, they are all now become conventional, okay, or nuclear. Although which is dangerous, we cannot avoid them. We need alternate source of energy, okay. So, then fuel cells, biogas technologies are also there, and wind, and even tidal power. Not only tidal power, okay. They are being generated at the respect to these things. Similarly, solar power, wind power, and so that distribution side the losses will be less. The transmission losses also can be reduced, so that straight away you can use. For domestic purposes, the alternate source of solar are very popular nowadays. Okay. Anyway, so why I'm telling is that cut set means a minimal set of elements whose removed from the graph isolates at least one vertex. Now, how they are related to the circuit theory point of view? What we learned is basic cut set from the graph theory using the spanning trees, using the Nassing-Dev textbook. We have got the definitions of those things. Algorithms are being available for generating the spanning tree. How a cut set is being defined. A fundamental cut set or basic cut set are simply known as F cut. Fundamental cut set is being defined as consisting of the set of elements with one and only one branch of a spanning tree of the remaining elements of the core tree elements. So similarly, circuit, fundamental loops like that. Now our approach is only cut set. Okay. So basic cut sets or fundamental cut sets are the ones which are being required like that. And we know the nodal equations are based on that. How many nodal equations are required for solving a problem is based on the cut set approach only. That is using the graph theory only, using the number of unknowns in the spanning tree only. A spanning tree implies having all the set of vertices in the graph with no loop is being present. It is a circuitless connected subgraph of the given graph. So it gives only basic cut set. Now how that is being related to now the power system network? Power system network is a multi-input, multi-output network. The multi-inputs are being treated as a combined thing together. They can be treated as a single input also. That's what we have made a model in the power system application. All the generating nodes are being connected to fictitious node called root. Okay. So source node is different, root node is different. Combination of all the sources at the various buses can be combined them together as the root node. That is the typical concept which we have done during our research using the graph theory. Okay, that is very popular in applications of the graph theory. I have done my PhD thesis entirely in generational cut sets and algorithms for cut sets, spanning tree, and paths. Path is for reliability analysis, cut sets for unreliability analysis. failure modes. So like that, developing the algorithms and application to the power system network and thanks to the load flow studies. That is my PhD. This is 1992, submitted 94. I got awarded. So I got that exposure in the multidisciplinary area, and later I found that it can be made as a multidisciplinary approach based on IIT Kharagpur and IIT Bombay. They have started MTech reliability engineering. That is how I could start in South India in only in Anantapur. Okay, right? Anyway, later we have got courses in MTech reliability engineering in National Power Training Institute, Faridabad, and one in Haryana, some university they are conducting this reliability engineering courses. Okay, so directly reliability engineering specialization are very, very less in number in the country. Okay, anyway, so what is cut shed I just mentioned. Now, if the cut sheds are related to the one particular node, which is a load point in the power system, that is referred to as output cut shed. So load point cut shed. What is meant by load point cut shed? If you consider the sets of the elements which are related to the load point, that means even though there are sources and other components are functioning, but this load point, because of the transmission line failures, there is no power supply to this particular consumer perspective of the load point that is being connected to the radial distribution network. That is also possible at a particular bus. So that is called output cut shed. Okay. Then, so there will whatever load point, there will be separate load point cut sheds will be there. But what is a system cut shed? A system means a power system cut shed. Ideally, from consumer perspective point of view or consumer perspective point of view, we say a system is a failure even if our power system is a failure, even if one of the consumers had a particular distribution point, near it is a transformer, near it is this one, the consumer, household consumer or industrial consumer says, no, power system, I am not satisfied today, I did not get the continuous power supply. You will always cut the power system only. Entire system, not the one where the transformer is failed and other things. That is the lookout of ourselves. Where the fault is being located, where the fault has occurred, how to rectify that is our job. Consumer as a layman doesn't want it. He is only user of the power supply, for which you are charging them. So therefore, there is a need to identify at various points. So output cut shed, system cut shed, load point cut shed. So output cut shed is same as the load point cut shed. System cut shed means failure of the power transmission to any one of the load point at which the consumers are being located. The consumer can be classified in domestic, household, or industry, or even government buildings, offices, etc., whatever it may be. It is a failure of the power system. People collectively say no current. It's not no current, no power supply. Okay. Anyway, now I would like to explain as far as the cut shed is concerned, how it is being represented. There is a pictorial representation of these things. What is meant by pictorial representation of the cut shed? Just I mentioned the definition of the cut shed is that removing of all the elements will lead to the failure of the system. Right? So that means as far as the probability logic diagram of the corresponding failures are concerned, all the components of the cut shed elements, all the components of the cut shed are considered to be in parallel. And remember, it is not a unique one. How many number of cut sheds will be there in a graph? Again, it's a problem. I have done some work in that long back. Okay. Simple technique is as nothing to has been given in the textbook is 2 power n minus 2 where n is the number of nodes. 2 power n minus 2 cut sheds will be there in a particular network. Okay. It is not the only one. It may be lower than the other one which I have devised, which is out of the context here. I will be deviating from the top. But we need to know how many number of cut sheds will be there. That is why reliability engineering problem is a combinatorial problem. Even cut sheds themselves are combinatorial problem. 2 power n minus 2 cut sheds will be there at most. Not that every graph or every network possesses those things. A maximum is 2 power n minus 2. Again, the graphs are dense or sparse graphs. Most of the power system networks are sparse in nature. A 14-bus network has got only 20 transmission lines. A 57 bus or 69 bus has radial distributed network will have only 68 transmission lines. Okay, 69 bus system will have only 68 transmission lines because it is radial. If it is ringman system, there may be based on the number of tie switches and other things that are required. So therefore, radial distribution system, if there are n nodes, there will be n-1 transmission lines only or distribution lines only. You may call them as distribution lines. They are power transmission lines essentially. We are only classifying them based on the length and based on the purpose which you are using. For domestic purpose or for industrial, these things are otherwise based on the area of interest and based on the type of the application which you are considering. Okay, so that is how the elements of the cut set are considered to be. That means if in a particular consumer point of view, 2 or 3 lines are falling, and the power supply is not being reached to the the tower or a junction or at a pole, street light polling place where the domestic users are not getting, consumer point of view, they are treated as the cut set elements. That means there is no power supply and power system is being failed, people will say. Consumers will say that. So that is treated as a cut set. So it is not that only these 2 elements if they fail. Even if some other point within the same radial distributed network, some other these things are failed, some other load may be failing. So because it is most of them, we have got single feeder system, later we have got multiple feeder with the tie switches and other things are there. Parallel feeder configurations are also come up in the literature. Okay, through the tie switches and other things. We consider only at the initial stages with respect to the single feeder system. So these concepts will make us to understand the probabilistic analysis of these things. What is the meaning of that? So the elements of the cut set are considered to be in parallel. And since each such cut set will lead to the failure of the system, from the probability logic diagram point of view, that is why it is called probability logic diagram. It is not reliability logic diagram. It may lead to success, it may lead to failure. We are talking in terms of this. That is why if system is functioning satisfactorily, no one bothers. If there is a failure only, people have to think about. That is why reliability analysis starts with where the failure occurs. When does the failure occur? The failure is with respect to the quality of the power supply, with respect to the voltage profile. No losses, ideally no power supply losses. And no interruptions. 24/7. Full voltage, the desired voltage profile is required. No losses. All 24/7. And the reliability must be high. 1. These are the idealistic conditions. Everything in the reliability analysis is as applied to power systems. We consider only 3. Voltage profile, ideal 1.0 per unit. Losses, 0, ideal. Then third one is reliability, always 1. 100% if you don't want to compromise. So these are all 3 which are highly impossible. So far, no ever system can achieve it. It is impossible to achieve, right? But we need to try to achieve for it. 99.99 we can say. Don't round it off. It may lead to the wrong number that it is 100%. We can never claim it. We can never achieve it. Improvisation. Then sustainability is what is required. Okay. So anyway, so it is in this context we have got these things. This is the elements of the cut set. This is the elements of the second cut set. This is the elements of the nth cut set, if there are n such ones. So these are the elements. How many elements we have considered? M elements are there in each cut set. So it is like n by m represented. That is why it is called parallel series configuration. The elements of the cut set are considered to be in parallel. The elements of the second cut set are considered to be in parallel. The elements of the nth cut set are considered to be in parallel. So each one of them is a stage as a optimization problem. This is one stage, second stage, nth stage. M components are there in parallel. Okay. So that is the approach. So cut sets now, why the cut sets are more powerful in any application is they represent directly the failure modes of the system. Even in the contingency analysis that is being done in the power system applications earlier to provide a ranking of the power system networks, those contingent elements which are being considered which cause the loss of the even load flow technique cannot be performed if some of the components are being done. That is called a critical line, critical transmission line. So the critical elements are essentially part of the cut set elements only. That is how the cut sets are being related to the, from circuit point of view, they are the obtained from the spanning tree to find the nodal equation solution. They are equivalent to the failure modes in the power system network directly. So the elements of the cut set are said to be in parallel. So it is a parallel network in that context. And each such cut set can lead independently. Mutually exclusiveness is there. There is no commonness in this. This is a different set, this is a different set, this is a different set. There will not be any duplication of the elements. There will not be any supersets also. Non-minimal cut sets cannot be done. That means we know from the Boolean sense, x plus xy equal to x, where x is a set of elements which lead to the cut set. Y is another set of elements. That may be another cut set or combination of the some elements which is having with x as a combination. Some elements which are combined. So x plus xy is x. So xy is a non-minimal set. That is why Narsingh Dev in his book way back in 1987, I had an opportunity to listen to his lecture at IIT Delhi. Now he's settled in US, maybe around in the world, with 80 plus, I don't know. Recently I have not seen him. In 1988, I had listened to his lecture here at IIT Delhi. Okay. He is an expert in graph theory. Graph theory with the application to engineering and computer science by Narsingh Dev, N. Dev. He is a PhD from IIT Kanpur, then settled in USA. He is one of the reliability experts using the graph theoretic techniques. He has used a lot of graph theoretic techniques in that context. Okay. So now coming to this particular aspect, the remaining slides are more as such, but the point is, I have to introduce the concept. Once I introduce the concept, I can only tell you case study. Case study, no separate fundamentals will be mentioned. What we have done, what we have got, whether you have got a better achieved result or not, only I can express. But why we have done in this direction only? Because I'm only in the 8th slide now, but I got about 50 slides. That is why I'm just telling. Okay, don't worry, it will not, I will not exceed 4. Okay. So, because the concepts are so trivial that some may be known to you, power system point of view maybe. But now even that I cannot assume because electrical engineers are not power system engineers now. Okay. People say we are electrical background with power electron specialization. They might not have only basic fundamentals may be there, but in-depth knowledge of the contingent analysis, banking, they don't know how to perform the load flow studies, etc. There are people. Yeah. So therefore, that is the thing. But the advantage of the power system people like is we are become conventional. The devices that have been developed by power electronic people for application to the improvement in the reliability of the performances, improving the voltage regulation, or even power transfer, etc., are more vital. That is why still a lot of research is there, and now they are classified as FACTS devices, flexible AC transmission system devices. FACTS devices themselves, power electron devices, advanced load sensor, FACT devices. Okay, so like that is well known. So that is the advantage. What devices they are using, that is their this one manufacturing process, utility point of view, we are using it, and the configuration, their properties, their application. So how to apply those things only we are of interest, like that. So that way that is a different point. So now this parallel series combination is being made into single equivalent one. This parallel equivalent one is being made equivalent to single equivalent one. So they are connected in series. That is why it is called parallel series. First, the elements of them are connected in parallel. So the entire parallel series configuration is made into series configuration. These are the elements in parallel. So each such cut set is considered in series from the probability logic diagram point of view, which lead to the failure of the system. Because any one of them failure will lead to the failure of the system in series combination. That is well-known concept. Simple fundamental concept. Why? It need not be reliability engineering, but it's a common sense point of view. In a cycle chain, even if one link goes, it is a failure of the chain. So the elements of the chain, cycle chain, are considered to be in series only, although it is a link. Okay, this is a closed one, but all the elements are considered in series like that. So this is a single equivalent one. Now these are the three indices that are being considered from the cut set point of view. This is for parallel combination of the elements called outage time. R is the repair time. It is same as MTTR, mean time to repair. It's also referred as outage time or repair time. These are synonymous terms. Based on the notation, R is the repair time of the component of the ith row in jth column. So like that. That is, one is the number of components, one is the number of stages, etc. So that is the notation. Derivations are there. It is not my interest to express the derivation part. Okay. Then what the IR represents is mean time to repair is outage time. These are the component value of the repair arm of the component. Component means transmission line or distribution line or a switch or a circuit breaker, etc. Okay. Among the radial distribution line, they may be serial. That is only. Now, sigma is summation symbol, pi is product symbol of RCIK. The notation is out of context. So, R is the repair time, right? R is the repair time of the component RCIK. RCI is for the cut set C1, C2, etc. Lambda is the failure rate, equivalent failure rate. For each component, lambda is the failure rate. That is lambda Cij. That is ith row and jth column. Maybe ith stage and the jth component, or in a cut set element, ith cut set and jth element. In a cut set, there can be maximum is, if there are n elements in the network, there can be of course n minus 1 together in that sense. Okay. Again, that is called cardinality of the cut set. How many number of elements is there in a cut set, and how many number of cut set is a different problem by itself. A lot of research work has been done. Still, it is a wide open problem. Application point of view, even software tools are available. There are software tools in Relaya Soft is there, and CYME is there, CYME, which uses reliability engineering, distributed system reliability tools. They want the inputs as the cut set elements, which are the failure mode. You give the data of the failure rate, repair time of the cut set element. Then what is the cut set? How do you define it? Unless the theoreticians or the academicians give the data of the cut sets, they cannot include them. They are not random. So some subject expert has to give the data of the corresponding elements of the identifying the set of elements. For that particular one, the statisticians will give the data, practical data. Based on the models that have been developed, they identify the probabilistic data also. So the practicing engineers have to collect the huge data, identify the randomness of the failure, and the statisticians will make the pattern of the particular statistical data of the probability corresponding component. Then we apply them to the system. So highly interlinked system configurations which we are talking about. So equivalent failure rate lambda Ci is given by this particular formula, where remaining are only sigmas or products, etc. Lambda Cij is the for component failure rate. RCIK, that is notation here. RCIJ is the for the same component repair time. This is the failure rate of the component. This is the repair time of the component. That's it. Rest of all notation with respect to the cut set element, outage time that is being predicted. This is the equivalent failure rate of the cut set. Now this is for the system. Now what is known as system? So CS, lambda CS, this is the element whose equivalent series component is made into system equivalent. So lambda Cij means lambda C1, lambda C2, lambda Cn, RC1, RC2, Rcn we have found based on the component values of lambda C11, lambda C12, RC1, RC12 like that. RC11, RC12. That is the notation that has been done. So double subscript notation has been used in this particular context to identify the number of the cut set elements, the number of the cut set, etc. And this is the parallel equivalent one is made to single equivalent one, and this second one, single equivalent one, nth single equivalent one. And all these n single equivalent ones are considered to be in series from the probability logic diagram point of view. Network reduction technique. Then this series component is being made into equivalent one. That is the notation of this particular one. So RCIJ for the individual component, lambda ij for the failure rate, this for repair time, this is for the system, cut set, RC1, RC2, etc. or else lambda C1, this is for the last one, equivalent one. Lambda CS is lambda CI sigma 5 from 1 to n. So like RCS similarly, then UCS. What is the difference between now RCI and RCS? There is no difference. In the sense, this is for the system. But now UCS is another term that has been defined there. For a series system, UCS equal to lambda CS into RCS. That means the reliability which has been defined is being considered only with respect to the value between whose value lies between 0 and 1. But power system engineers will not be satisfied. How many number of hours per year there will be power supply failure to the consumer perspective? Don't mistake me. I am not criticizing our own system, but it is our responsibility to think about it. In the literature which I have got, they may consider Billington book people in the world where they are the pioneers. As I told you, he is the number one in the world, even today. Roy Billington. Okay, even today. Okay, he is the chairman of the reliability subsection committee of the IEEE. Okay, now in Indian context, we say how many number of hours per day or how many hours the power supply is being given per day. It's a really unfortunate scenario. But we as power system engineers are responsible for this maintenance of this as a whole. I'm not talking about the individuals. So whatever be the constraints, still we are unable to say that we are not able to give the required standard power supply sources to the consumer perspective. It's a wide open problem. I'm not talking about who is responsible for this. How to mitigate these things and how to maintain the voltage profile, how to maintain to the most desired levels. Always there is a possibility to improve. So that is why when we talk about the reliability point of view, we think that people think that we criticize others. No. Unless we know what is the failure and what is the cause of the failure, how can we rectify the system? So therefore, if you want to get that particular one, you have to give the correct data, not fictitious data. So if you hide the data, results will be wrong. So if you correctness of the data is also absolute necessary. That is important. Right? Anyway. So this is the equivalent failure rate in failures per year. They are called annualized indices. Annualized indices. This is called outage time of the system. Okay. And this is that is in hours. Okay. And this is UCS. Average annual outage time. Average annual outage time. This is in hours per year. That means how many number of hours for a particular year the consumer or a system is unable to give the power supply. There is a disturbance in the load. Disturbance in the load means power is being cut off or low voltage so that they have to switch out their domestic appliances. There is no otherwise, or even industry purposes. It is not a complete blackout. Total system collapse means that there is blackout. So system point of view is, which I have defined earlier, which was accepted, is that system cut set implies any one of the load point, any one of the consumer failing. Otherwise, earlier people used to call in power system point of view only cut set of the output, cut set of the load point and other thing. What about the total power system? Any one of the consumers. So which is equal to union of the corresponding cut sets. So segregate all the cut sets and there should not be any repetition in this. So they are the system cut sets. That is the meaning of it. Anyway, so this is about the definition of the cut set and application of these things. Now, I would like to go through this particular one through an example. So I have given you, I am on the, I have told you I will explain with the three objectives. One is cut set approach. Second one is network configuration or network reconfiguration. Third one is with DG. So I am with only in using cut set. So slightly today I may exceed the time because the topics sometimes may be relatively new to the audience. If they are the same students, those who have studied this particular one or those who are teaching may not be new, but I expect even if one doesn't know about these things, I thought I have to make it in a global sense. Because even if one gets benefit of this one, for the entire this one, you get the awareness about the practical problems of how to analyze the reliability of system. This would be one of the topics that can be useful. Then you can see the same person which I mentioned, Roy Billington. The 6-bus test system which is being identified is defined as Roy Billington test system by IEEE reliability group. Okay, that is why we always talk in terms of the IEEE most of the times. I got the opportunity to be the founder chairman of the IEEE subsection in the board. Subsection covering all the 5 districts of Rayalaseema, 4 districts and Nellore district also. And I was the past chairman, 2009, up to 2019 I was there, right? Now, this is a sample case study. It is a 6-bus system. Okay, these are the 2 generator buses where you can see not single generator, 2 40 megawatt generators and other thing. And there are models how to evaluate the reliability of such generating systems as a whole at a particular bus also. I am not going to discuss. Now I will be telling you what we have done and what are the results only. Okay. Then there are one generator of 40 megawatt, 4 and 2 units of 20 megawatt and 5 megawatt respectively. And these are the 6 buses, 1, 2, 3, 4, 5 and 6. And you can see there are 5 load buses. Here, of course, not connected, not shown to be connected. Bus 2, that is, this is taken as slack bus. Bus 2, 3, 4. You can see the arrow marks are represented in the load point that we know. So, load point at bus 2, 3, 4, 5, 6. And there are 9 transmission lines. So, it is a composite power line network. And there is a double circuit transmission line at the corresponding bus 1 and 3. And also at bus 2 and 4. From reliability logic diagram point of view, these two are combined. While drawing the graph, 1 and 6 are combined and equivalent component failure rate and repair out times have been computed and then they have been obtained. So 2 and 7 similarly like that. So the graph of this network is simply brought down like this. Okay. So you can see that is what I said. 1 and 2 have been combined and put it as a source. Okay. If there is a source from graph theory point of view, that can be treated as a root node also. Root or source node is being same here. So it is not 12. That is, it is 1-2 combination. That is 12th node, 12th that is being identified because let me tell you. Yeah, 1 and 6 are being there are 9 elements. So 1 and 6 are combined to element 10 parallel combination, right? And the 2 and 7 are combined to as the 11th combination. So a line equivalent one is 10 and 11 have been identified. These 12 and 13, what are those? They are fictitious. Generator buses are 1, 2, 3, 4, 5, 6. You know, encircled ones are buses. We know that. So these two are connected to as a single node. That means the multi-inputs connected at the buses 1 and 2, that is generators, are being treated as a single input as far as the power system network is concerned. The multi-input network is being now treated as from the graph theory point of view. For obtaining the cut-sets point of view, treated as a single input network. There's nothing wrong in that. Because we have combined. Whose probability can be taken as one? Doesn't matter. Initially, otherwise, whose probability is same as the probability of the generating units? Whose probability is taken as the probability of generating unit? So that way, so 12 element is generating unit. 13th is connected bus 2 to the source node, okay, or root node. Some people call it fictitious node also being generated from the algorithm point of view. I am not explaining those things because I have done and several algorithms those days 3 decades ago. But later nobody is having interest in graph theory to be developed. But I am studying and understanding those things. Other algorithms we are trying to do that. Anyway, application part only we are doing. Graph theory we are not doing. And anyway, so now you can see what are those cut sets. Now you can see if you remove the elements 12 and 13, that means both the components of the generating unit may fail at once. It is possible. There is a flag. Sometimes generators are not functioning. What are the reason? Suppose it happens. How to obtain, how to model. That is our aspect. Then if both the, so that is called one cut set, which is minimal. So that isolate the source node itself. No possibility of reach into that node. T, that is the terminal node. So source node is S and output is the load point, right? So here, correspondingly, you can see that is why PLD of LP2, that means probability logic diagram of the load point 2, that is output at bus 2, that is LP2. LP means load point. Probability logic diagram means cut sets. So the elements of the cut set are in parallel. These elements are cut set in parallel. Each set, there are 5 cut sets here that have been identified, which are considered to be in series. You can see this is the each C1, C2, C3, C4, C5 are connected in series. The elements of the C1 are connected in parallel. That is the meaning of the cut set approach. Why we are more popular in using cut set approach is FMEA analysis is there. FMEA analysis is there. Supplied by Item Tool software. In Bangalore, they are supplying also, which is originated from USCA. Okay. FMEA analysis only makes about 2.5 lakhs. FMEA is again 2.5 lakhs. Total reliability software tools package is 27 lakhs. Only with respect to the reliability logic diagrams and other things and spare parts analysis and other things. There are about 11 modules are there, costing 27 lakhs. So if at all you want to apply for a reliability project for analysis, you can always ask for DST funding for these things. I can give you the input for that. So similarly, exclusively distributed system load flow pattern, solving the problems and capacitor placement, optimization technique, capacitor placement, and cost optimization. So many things. Our power systems, distributed systems, interconnected systems, Siamese distributed system. Like that layout software is there for general classification, and ABB, Asia Brown Boveri. ABB software tools are there in reliability analysis. There are good number of worldwide standard software tools are being available. And in India, only one major dominating one is PRDC, Power Research Development Consultants. They do some part of reliability analysis also. They do with respect to production, and they are the major consultants for all the state level distributions or even national grid connections, even to central electricity authorities, which is located in Bangalore. Power Research and Development Consultants Limited. They conduct the tests also, or even online interviews, even to take the intern project students. They guide PhD students also for practical solution problems, including reliability analysis also. I am not putting these things in these things because I should not canvas for the people, but I should give you the information. If you ask me the data of the address and other thing, I can give you if you are interested. And the organizers can give my email ID and phone number. This material also will be given to you already. It is being forwarded to the organizer just before start of my lecture. So earlier lecture already had been given day before yesterday itself. So I request the organizers to give the material to all the participants.
Sure, sir. We will share the things, sir.
Yeah. So these are the cut set representation. This is the block diagram representation cut set. So similarly for the other, I don't want to explain those things now. Okay, because now I'll be losing time. So you can see how many number of cut sets are there and how many. You can see there is only one element in this. That means if 9 component, the component 9 is failing in the network. Sorry. Yeah, this is the 9th component. First 6 is getting isolated. So this is called a cut set having one element only, like that. So identify the cut sets like that. So load point 6, these are the number of cut sets. So 14 cut sets are there for that. Because that is at the fag end of the radial distribution network, right? So that is the point. So this is the data that is being based on some reasonable data we have taken, but I have that liberty in choosing the fictitious data also. Because I observed, don't mistake me, Roy Willington Group have given in America, they have given all ideal conditions data. Okay, maybe they are applicable in their system. They claim few minutes of power failure they consider huge in USA. But in Indian context, it may not be feasible. So for making our analysis to be more logistical, which was approved, which was published in papers, I have assumed some of the fictitious data also. That is reasonable, realistic, practical data. Okay, for assumption only. Okay, so failure rate is failures per year means 0.4 failures per year means the reciprocal of this is the mean time to failure are called operable time. So 1 by 0.4 is 2.5. That means what is the meaning of the branch number 1 or 6 can fail at the rate of 2.5 years per year. That means once in 2.5 years, the component is likely to get overloaded or giving start problems. Okay. Ideally, it's 10 years. Transmission line 10 years. Transformers say 35 years if you maintain periodically by replacing those things. A bulb, 0. The moment you purchase it, there's no guarantee. No one gives you. You test it there, but you bring it to the home and then test it. Again, you go to the supplier and say, you have given, no. Your network may be bad. That is why I ask you to test the bulb and then only take it. Otherwise, it is not guaranteed. You cannot even claim for it. So, but it does not mean that we are not manufacturing the bulbs. No analysis has been made. So, with 0 reliability, no guaranteeless, means the moment you take and test there, by the time you bring it to the home, or by the time you install, it may blow off. But still, no guarantee is there. No guarantee is there. But still, you have to make the products to be more reliable, right? Anyway, so this is the estimated assumed value, and This is also repair time for certain transmission lines. People may say 1 hour or 2 hours like that. So practically, it requires. Suppose it goes in the evening. No repair will come in the corresponding one. The actual time you have to wait for some 12 hours till next day till the lineman or the electricians will come into the picture, do it, supply cut off to the other zone and other things. We are not doing live replacement, although it is there in the world. In some of the countries they have been using. Still, in our sense also, where there is some places when they are in high voltage side, they are doing it because they cannot shut down the power supply. So live replacements have also been made with appropriate protective systems and other things. I know in the literature even 2 decades ago, but we are not doing those things. Okay, so 24 hours is randomly that has been achieved. So based on that and the data that is being obtained for this for branch number 12 means generated data based on the actual data we have converted that. So this is the equivalent failure rate. This is the failure rate of the lines. This is the equivalent failure rate because there are more number of generating units are also there. Components I mentioned in the network and mean outage time in hours. That is repair time. Mean outage time, average outage time or repair time is same. MOT, right? So this is the data. That is based on the data that is uniformly all are made equal. There is no need that they must be equal. But this is the one assumed data. So similarly, failure rate is assumed same as the equivalent failure rate which has been computed. There is nothing wrong. Okay, number of units are there, 4 and 7 like that. Okay, for the 12th unit, 12th element branch, whose generating probability with 4 units have been assumed to be failure rate of 0.4. It is 60% of the failure success rate only. Failures per year, okay, 0.4. That is 2.5 years of the generating units all can fail even one of the components which lead to the delayed performance or total collapse of the at that particular cost. That is the meaning of this. So you can see these are the 3 being computed based on those formula. Okay. BPA means basic probability indices. Lambda CS, RCS, UCS. Lambda is equivalent failure rate using clustered approach. The final value for the load point 2, load point 3, load point 4, load point 5, load point 6 and system. And RCS, that is the average outage time for the load point 2, 3, 4, 5, 6 and system. And UCS, most of them people used to refer to the consumer perspective means load points only. But from at least one of the consumers, you have to consider the system also, power system point as well. Okay. So UCS is average annual outage time. That is why the units you can see. Hours multiplied by failures per year is hours per year. So lambda CS into RCS is UCS based on that. Okay. So this is the corresponding data. Now we thought about how to improve this. This is the best case one solution based on the estimated data. Now we try to change with keeping this as fixed. We change it, reduce the repair time by half. That means instead of 24 hours, can we calculate? Can we imagine that only 12 hours is required? So suppose it fails in the morning, by evening can we repair it? That is possible. That is the basic point in which we are reasonably assumed. Practical, some statistical data. Then remaining things are being made same. You can see the difference in the data. This is 0.4 retained same, and this we have changed from 24 to 12. That's all. Again, it is fictitious, but it is reasonable assumption. So that we want when the morning power supply fails before evening sun sets, we want the power supply to be required to the consumer. The worst case. Ideally, 1 hour replace we expect within 10 minutes. But we, as teacher, we may say, but practical, we have to call the people, all those things, it may take hours together sometimes. Okay, they must be free and availability of the sources, availability of the material, and practical problems, all those things we have to consider. So 12 hours we thought it's a reasonable time. So with these things we have got the corresponding data. Of course, I could not make it a common data now. I have an example. Lambda CS, RCS, UCS for each of the load points we have obtained, and this is the system. This thing. Now you can see when with 24 hours of the repair time that is being considered, keeping lambda is constant, we have got 1.79 is equivalent failure rate of the system of this, and for this 0.225. So 1.79. From 1.79, the equivalent failure rate has been reduced. If the failure rate is reduced, then reliability will increase. Because A fundamental property of this exponential distribution is R of t equal to e power minus lambda t. Even chemical compounds during our atomic structures and intermediate in chemical engineering, chemical chemistry study, we know that chemical compounds deteriorate or decay exponentially with respect to the corresponding component. The same as this one here. The reliability of the component is decaying exponentially means e power minus lambda t. As time tends to infinity, it becomes 0. At time t equal to 0, it is 100%. That is the meaning of this. So, based on the exponentially distributed rate of the components that is being assumed, initial models, all the data is exponentially distributed. Constant failure rates are treated as failure rate. That is a probability theory. Even system reliability concept is there. Of course, as I said in the last class, I could not give every detail of that. That is true. I have presented the advanced topic of optimization techniques. So basic system reliability concepts we used to explain this fundamental aspect of the exponential distributed one. So anyway, one improvement is at 1.79 to 0.225 for the system, right? So similarly, the average annual outage time 10.7, you can see hours per year. That is 10.8 hours per year to 0.68 hours only per year. That much of increase is there. So it is not optimized one still, but it is an improvement only. It is not done by mathematical sense, but it is called heuristic approach. That means the mathematical models are being there for prediction of the reliability response. For application to the power systems, in this particular approach, we have made heuristic approach. We have shown the improvement. So there is an improvement in reliability. That means we try to achieve greater reliability of the system by increasing. So reduction in the, that is from 10.8 hours to 0.68 hours only per year. Remember that. So unavailability we mentioned. That means out of 8760 hours, hardly not even that much of 0.68 hours only. That 0.68 hours means 0.6 into 0.7 into 6. That is 42 minutes only. Roughly 42 minutes. Okay. So like that, there is a definite improvement in that. So that is how we say we have improved the reliability perspective. The performance has been improved. Okay, next one. So like that we have done for keeping the this 12 hours fixed. We change it from 0.4 to 0.2. Okay, uniformly, just to test that one. And the table has been obtained. Similar comparison has been made. These are the corresponding results because I have to explain two more. Already I have just now observed that it is 3:30. I have to finish off in the next 20 minutes so that question and answers will be there. I don't want to take your time. 2 to 4 we started just 1 or 2 minutes only late, but we have started on time, I can say almost. So because the introduction of the topic is to take more time because these things we can understand the results clearly once you know the concepts. So as the number of persons are increased, lambda and u will increase naturally. That is a simple fundamental logical conclusion that has been considered that will be obtained in this case also. Now typically this is the conclusion. When repair time is reduced from 24 hours to 12 hours, keeping the failure rate constant, that is lambda constant, all lambda of the each parameter, each transfer line generator, whatever the data that is being there, that is being treated as constant. All equivalent parameters are decreased. All equivalent parameters are decreased. That means there is an improvement. What are those equivalent parameters? They are not the reliability parameters. They are the parameters which are leading to the failure of the system. You can see equivalent failure rate. Outage time, we have not said that the operable time. It is outage time. MOT is not mean operable time. Mean outage time. That is failing time. When lambda is reduced from 0.4 to 0.2, keeping R as constant, average outage time is decreased. So that is the property that is required. Average outage time is decreased means reliability is increased. So that is important. From 10.8 hours to 0.68 hours roughly. So there is a reduction in the UCS or number of hours per year of the failure. It is a failure index. That is why it's called probability indices, basic probability indices, right? So RCS is increased. That is outage time is increased. Even though outage time of the component is increased, but system point of view, it is still increased also. That is system point of view, RCS is increased also, but UCS is decreased still overall. That is important. These are some of the properties that have been obtained. Now, I would like to discuss with respect to the radial configuration same network with power system application point of view, which is very conventional, but we will embed the reliability one also. You can see this is a 6-bus distributed network, single feeder. Okay, this being treated as the slack bus, and this is the tie switch between the buses 3 and 5. There is a tie switch that has been considered. That is why it is shown as dotted line. So without the dotted lines, it is a base case network or basic reliability, basic configuration with 6-bus with the corresponding component here that is being shown. Okay, with this particular component that is being shown with tie switch, that is the reconfigured one. So the load flow solution, radial distribution system has got a different load flow solution technique because R/X ratio will be more than the conventional for the Norton method, which is non-convergent. So you have got a distribution load flow solution is separately being there. Okay, that is popularly known, and our research scholar has developed MATLAB programming about 5 years ago. So power loss is the expected value of this one is same as this for the base case network, calculated value and simulation result. So to prove that the corresponding simulated value, because MATLAB simulation people are always criticizing. We know if you don't develop any theoretical calculations or another program, by giving MATLAB program tools directly injecting the values, whatever the results you are giving, you are taking it as granted. That should not be the case. We strongly recommend not to use MATLAB for verification purpose. Unless you verify the MATLAB results, you can always do, but you have to do it either by a theoretical study or calculated value or develop an independent program and get the solution methodology of the corresponding transfer functions that have been used in the block, which many times people have not been doing it. So for small studies, sample case systems, you have to do with theoretical calculations. For large systems, of course, anyway, theoretical calculations is not possible, not impossible, but we say not possible. Okay, but so that is right. So the load point indices formula are just mentioned here, same with the notation that is being shown, same as this one, but not with respect to the concept. Why the formula slightly seem to be different is that from the average failure rate or mean failure rate or equivalent failure rate is called equal to sigma of lambda I, because from the radial distribution point of view, from the input feeder to the load point, all the components are considered to be in series only, including the bus bars, circuit breaker, transmission line, disconnector, anything with respect to given load point, because it is radial configured. It is not a single main configured. So all the elements are considered to be in series. So for the exponential distribution, equivalent failure rate equal to sum of the individual failure rates. That is how this formula has come up. So rest is same formula, same notation. So that is the average outage time also, sigma of lambda into Rs, and R equal to U by lambda. These are things that is component wise the data must be known for each of the elements connected between this is the transmission line, this is bus bar, and this is taken as a generator one, or maybe this is taken as a unity, because we do not consider the failures up to this point. That is generation and transmission, it has come up to this level, and this is the slack bus. So like that, based on which data you are taking, only we have considered the generators data and the corresponding transmission line data. Bus bar failures are not being considered. Adams and graph theory analysis with respect to the vertex failures also. That is a different context. So these are the performance indices. This is too elementary for those who have studied the power system reliability subject. Otherwise, this needs to be explained. As I told you, for each of the subsystem there are different indices. Okay. So generation system reliability analysis, transmission system reliability analysis, loss of load, loss of load probability, loss of load expectation, loss of energy expectation, etc., or loss of energy for all those things for simple cases. So for small systems or for any systems in generation system reliability, like that we have got SIFI, total number of customer interrupts, that is system average interruption frequency index. Formula is given. Unit is failures per year. System average interruption duration index. Okay. It is an index means does not mean that the value lies between 0 and 1. Again, it is hours per year. Here the frequency means number of occurrence, not the power supply frequency. Frequency of interruptions. And this is the duration. Now this is CAIFI. CAIFI, that is customer average interruption frequency index, which is total number of customer interruptions divided by total number of customers affected. Here is the 4-decade definitions given by Belinda. Still we are using it. They are not outdated. 4 decades back, Belinda has given in his book. They have done research, and 84 was the first book that is being published, 1984. 70s onwards, they are very active researchers. And later they have become policymakers. Okay, so CAIFI, and these are the frequencies per year. That is number of interruptions per year. Customer average interruption frequency index. So SIFI, CAIFI, these are related to SID. Then CAID, total duration of customer interruption. Duration, this is frequency, this is duration. Frequency, F means frequency, D means duration. So similarly, system point of view, customer point of view. Then average service availability index. Customers, our service availability. That is why 8760, that is what it is expected. We want 24/7 power supply, all 365 days per year. So these are called annualized indices. We are not making it as a slogan. That is our right for the customers to get it. Are we able to do it or not is the responsibility of the power engineers, power system engineers. Okay? I am telling it as a slogan because that is 24/7 power supply anybody expects. Why? Why people should be deprived of that? Okay? So 24/7 power supply throughout the year because it is annualized indices with no extra cost, with voltage profile to be maintained properly, no losses, ideally no losses, and reliability of these things to be also proper. That is the meaning of this. So these are again cut sets have been shown, and based on which we have calculated the performance indices. This is only to show the calculated value and simulation result to be same or almost same, exactly same, based on some level of accuracy also can be made. So these are the indices that have been based on optimization using network reconfiguration, right? So you know, I don't want to explain now. I will only explain the results. I hope the audience know about what is meant by reconfiguration. Otherwise, time is running out. Algorithm also is being developed, and these are corresponding results: real power loss, reactive power loss, total power loss after reconfiguration. That means it is observed that the corresponding line earlier B4 is being shown to be between buses 4 and 5, and sixth one is being shown. You can see that. So recall just for 1 minute. Yeah, 1 second. You can see fourth one is connected earlier, sixth is shown as type shift. In order to make the corresponding one based on the data that is being obtained observing the voltage profile where it is the least of the voltages and based on the algorithm that is being developed. Now there is no time to explain about the algorithm. Our system engineers can understand. And also we have introduced the voltage stability index also in this, which I have not explained. There is voltage stability index is a parameter for maintaining the voltage within the specified tolerance limits based on meeting the required these things. It is one of the chapters by itself, and voltage stability is another subject by itself, which is very popular now since a decade now. Even we have introduced that also as for power system engineers. So keeping voltage stability index as one of the parameters also that has been considered with reliability also. And you can see after reconfiguration. So this is 0.47 and before reconfiguration 0.49, like that, one of these things. So like that everywhere there is a improvement in this, except for there is a decrease in unavailability, therefore there will be increase in the availability. So that ASUI I mentioned, ASUI plus ASAI must be equal to 1. That is obvious because this availability index, U means unavailability index. Some of the availability plus unavailability equal to 1. Reliability plus unreliability must be equal to 1. They are two complementary, mutually exclusive and independent units, independent properties. So that in reliability literature, the value they are 0 and 1 means the sum of the corresponding failure and success must be equal to 1. That is the meaning of that, right? So that is how the corresponding improvement has been made. You can see in every point that has been improved. Anyway, now I briefly mentioned about the network reduction reconfiguration I have mentioned. So similarly, we have done this with the third objective. DG placement, that is distributed generation placement. Placement of DG, placement of capacitors for distributed system, improvement in performance is always a vital aspect. Now includes the reliability aspect also. Reliability optimization means improvement in the performance. Okay, but optimization means minimization or maximization. Maximization extent, that is end of the maximization point is not being mentioned, or minimization point is not, less than boundaries have not been defined. But whether there is improvement or not, to some extent it is optimized, not maximum optimization. Okay, right? Global optima, local optima, like that. Not optimization to the desired specified case studies, right? Not the entire. For no single optimized index is being available for any system for that matter for the operating system. That is always there. Still, people have to find out that, and that is not possible as on today. So, still a lot of work needs to be carried out in this particular direction. So, distributed generation concept, I don't have to mention it here, and of course, which is to improve the not only reliability, improve the voltage profile, reduction in losses, maintaining the voltage stability index within the tolerance levels, etc. Okay. So the objectives of this one is these things essentially, and placement of the DG with respect to this MATLAB simulation. This is where we got. I don't say we have to criticize ourselves, but we have done the MATLAB analysis. For others, we have got the analysis that can be done, mathematical treatment, and other things are there. For reliability, we can have the analysis, but what type of size and the capacity of the distributed generation is being used, that is randomly being selected using MATLAB, and the results have to be validated. We only said that there is an improvement from previous to this one, not based on the mathematical sense or based on the other parameters. That is where the problem lies in applying the corresponding one. So large scale integration of, and you can see reduction of losses, improvement in voltage profile, reliability improvement. These are the three main parameters which I already told you, right? And large scale integration of distributed generators at either LV or MV side is the present trend. That is 6 years back. Even now, it is now replacing the total generation. Even fluctuations, it is able to take the variable loads to some extent. How much variation again is a subject matter. So that is what the big data analysis people are doing it. I have sent some of my students to big data analyst group for their MTech thesis projects. Okay, in Hyderabad-based one industry person has been doing this particular analysis. There are software tools also coming up, and the optimization principles of the things are also being done in this particular one to analyze the power system problems. He is basically an electronics engineer, but he is running a small scale industry with applications of the power systems with smart grid, embedded systems, VLSI design, and as well the reliability applications of the power system networks, the microgrids, all those. So there are possibilities in making these things. And I was told Pune Institute of Pune Engineering also recently I heard about the lecture from one of the faculty, Professor D. Sureka from Pune Engineering College. Under IEEE, he has explained about what are the greater opportunities in reliability analysis, also in campus opportunities in power sector. 2 lectures I listened to her in under IEEE organized under another subsection. Right? So all these things are, why I'm telling overwhelmingly is that with enthusiasm to you, I don't know whether you are able to receive that or not, that these are the problems which we have to tackle, and it is not the end of the research. once you completed research or you are pursuing research, that is only beginning of your career. Continue that and make others to get these problems to be solved, guide them in the right direction, and research starts only when somebody has ended. That is where it begins. And research begins where from empty. That is where somebody has not done. Okay. So always we have to carry forward these things. That is where it is not quote by given by me. It is given by some famous scientist. I do not remember the name right now. So research begins at what somebody has done it. So from there you have to improve upon. The original research starts from nothing. So you have to see search for the. So creating something from nothing is what is research essentially. So your research is never ends. It is a continuous learning. So improvement is always possible to even a small bit from one point to the other. So it's not only LV or MV side, low voltage or medium voltage side, but now even high voltage side also is coming up. And with the high power capacities also is coming up. But still, it is not yet complete. But now people are thinking in terms of high transmission system, high power generation system, megawatt, even gigawatt generation. As I told you earlier, 175 gigawatts of power generation is required through alternate source of energy in the upcoming these things, and all those things is there. So distributed generation and okay. And we have employed only adopted only photovoltaic systems, not wind turbine. These are the fuel. These are three options which are very popular nowadays. So these some of the results which I would like to mention. 33 bus system original network having originally we thought DGs can be placed based on the voltage profiles at the 3 buses where the voltages are less than the threshold. Based on the data, of course, I could not give so many details here. It requires a lot of. I can give the references. It is Lifemark's research paper which was published. So original 33 bus system is available in the data. It is not. It is a radial distribution system. 33 bus system, 69 bus are available in the literature also. Even you can Google it. Now, the randomness of selected data is based on the data of the load flow solution. We have found that at the buses 17, 18, and 33, there is a requirement of the power that is being required in with these capacities. That is randomly being selected because of the load flow calculations that have been done, where the voltage profile is less, losses are is less than the threshold. So we identified 3 locations where it is less than that. It's not that only one need to be placed. Multiple digits also can be placed based on the requirement. Ideally, to start with, it is voltage profile that is the prime concern. If the voltage profile is less than the threshold value, okay, which is maybe for theoretical purposes, we have taken it in 0.9, ideally 0.98, but reasonably permissible 0.95, but ill conditioned is 0.9. Less than 0.9, it is the most worst case. I think we have done up to 0.9, if I remember correctly.